Hey, Industrial Talk is brought to you by CAP Logistics. You want to minimize downtime? Absolutely. Increase reliability? You bet. Ensure operational profitability? Yes, you do. That means you need 24/7, 365 insights into your supply chain. Look no further. CAP Logistics. Go to caplogistics.com or just call them. They're great people. 800-227-2471. Also, AI-. AI- is on a mission to create a greener, cleaner, safer planet from space. AI- helps core industries become more resilient, efficient, and sustainable through the power of satellites and AI. Go out to AI-.com. Find out more.
Welcome to the Industrial Talk Podcast with Scott McKenzie. Scott is a passionate industry professional dedicated to transferring cutting-edge, industry-focused innovations and trends while highlighting the men and women who keep the world moving. So put on your hard hat, grab your work boots, and let's go.
All right, welcome to Industrial Talk, a platform, a global platform, an ever-expanding industrial ecosystem that celebrates industry heroes, you, all around the world, because you're bold, you're brave, you dare greatly, you solve problems, you collaborate, you innovate, and you're making my life and many around the world better. Thank you. That's why we celebrate you. This episode, we're talking simulation. We're talking about the technology, the solution that can simulate action, and so you can hone in more. It's exciting. We're talking with Ralf Haller, Executive Vice President with NNAISENCE. So let's get cracking. I'm always into simulation, and it's just getting better. Plug in some data, define your parameters, keep on going, keep on refining, keep that asset up and running more and more each and every day, and be able to simulate solutions before you even invest in them. I mean, look into solutions such as what NNAISENCE has out there and what Ralf was talking about. It's important to do that. All right, before we get into that conversation, we have 18 days for IMTS. And you're saying to yourself, Scott, why? Why should I attend IMTS? Outside of the fact that it is the largest manufacturing show in this country. It's got multiple floors. It's an amazing time to be able to collaborate. That's IMTS. Well, the reason is, and I'm looking out at their website, which is at imts.com, and it is powered by a company called AMT. What we have is you got 90% of the visitors found new products and ideas. It's right there on the website. I'm not pulling this out of my ear here. Inspiration. 88% of the visitors found new solutions. Yes. You need new solutions. You need to figure that out. And a community, 93% of visitors met their goals at IMTS. That means job shopping, women making manufacturing moves, investor forum. It's all there. IMTS. And the date's September 12th through the 17th. It is in Chicago. How can you complain about that? Food. Because everything wraps around food. IMTS, go there. If you're in manufacturing and you're not there, you're missing out. That's the bottom line. All right, back to simulation, back to data, back to the ability to be able to simulate what is going on. NNAISENCE, Ralf, do an excellent job. Open architecture. It's an amazing time. So therefore, let's get cracking with the conversation. Get your paper and pencil out because this is what it's all about. So enjoy the conversation with Ralf. Ralf, welcome to Industrial Talk. Thank you very much. All the way from Geneva, right?
Actually, I'm in Zurich, but the company is in Lugano, in the south of Switzerland. Hi, Scott. Nice to be here, and thanks for having me.
It still sounds great, and that whole part of the country or the world is absolutely spectacular. All right. Listeners, we're going to be talking a little bit about evolutionary algorithms. Don't zero out on this. This is an important conversation. It is an important solution, and it is open source, and it is it's just needed for many applications. And NNAISENCE just launched a product called EvoTorch.ai. You can go out there, but it'll be out there on Industrial Talk, and you can find out more. But the best part about it is open source, which is pretty doggone cool. Before we get into that conversation, Ralf, give us a little background. Give the listeners a little background on who you are.
Yeah, I'm in charge of sales and marketing at NNAISENCE since now about 2 years. The company exists since 8 years. We're still a startup, I would say, although we have many customers, also very large customers in the industrial space. I myself, nearly 30 years in high tech, also been in Silicon Valley for 6-7 years, helped to launch one of the first gigabit Ethernet switch routers long time ago. Since now nearly also 18 years in Switzerland, and first had my own company, but NNAISENCE is a super interesting startup, very much Silicon Valley style, that attracted me. And since about 2 years, I'm there and help to develop the customers and market the company. Yeah, so I'm by training an electrical engineer. I have a master's degree from German, very respectable university, Karlsruhe, and also studied in Silicon Valley, the data engineering.
So let's dive right in. NNAISENCE, we talk about evolutionary algorithms. What's the problem? What's the issue that we're addressing in this conversation?
Yeah, so ultimately it's complex, but let's try to maybe first start with an analogy. Only about 10 years ago, everyone started to talk about the application of deep neural networks, and they were very promising to solve lots of nonlinear problems, literally in any industry you can think of, right? But the problem at that time was you didn't have any compute environment to really run this and do it. And then there came the GPU. It's a technology that was used for something different. So graphic cards. But the notion there was that you had to parallelize things, and that it turns out these deep neural networks they worked fantastically well on these parallelized compute environments, GPUs as well. And the founders of the company, they were one of the first, if not the first, to run these deep neural networks on GPUs, and were even thanked by the leader in this space, the CEO, a few years ago, for doing so in front of thousands of their employees. They were never paid for that. That was one of the reasons why then we started 8 years ago the company, to monetize that and not just be scientists who are doing things for the community. And now we have a situation where, of course, the problems get more evolve, get more complex. We have situations where you don't have to solve just for one objective, but you have to solve for multiple objectives, so multiple goals. Like it's in practically speaking, it could be that you try to improve the quality. At the same time, you try to also do this, of course, very low cost, but this might be different angles. So, you cannot have both, but you want to have and many other objectives that you can think of. And at the same time, you have lots and lots of knobs to change, lots of input features and parameters. So these problems are called multi-objective, large-scale optimization problems. And to solve that, there is actually deep neural networks are pretty bad, if not even impossible, and will take you ages to do this. Will be very, very expensive, compute expensive. You literally have to spend hundreds of thousands of compute, which only the very big tech firms can afford. And OpenAI has spent millions on just, for example, for the shadow hand training that they had brought out 2-3 years ago. These guys well funded by the richest person in the world, and when big IT company, they can afford it, but of course the normal companies out there cannot and don't want to. And so there is a compute environment, a new compute environment needed, and this is exactly where evolutionary algorithms and evolutionary computing comes in. They are also highly parallelized, and it's very important that you can do this conveniently. And this is exactly where EvoTorch, our platform, has evolved over now, literally 8 years. We have worked on that, have done lots of projects, real world projects. I can talk to them in a minute. And of course, the desire was to now, after this is field tested, to also make this available to the world, the whole machine learning community. And industrial is one area where this can be used, but it's literally infinite areas where this applies, because these optimization problems, that's just about anywhere, right? You can think of.
Let me put on my, for lack of a better example here, my manufacturing hat. I am a small to mid-sized manufacturer. I have a desire to be more competitive, have greater insights into what's happening on my line, or whatever it might be, what my objective needs to be. And then, of course, with that, I desire a greater resilience in my business. So I have some long-term, and I'm competitive, and whatever, all of the drivers that I'm so passionate about. Where do I, me, small to mid-sized manufacturer, where do I even begin? I'm saying, I hear you. I sort of understand. What do I do? How would I proceed forward? What's my steps?
Yeah. So in order to make this work, you must have a simulation environment to start with. And this is very obvious, because you can, of course, not try to play around with an existing running industrial processing plant or a manufacturing facility. You know, your customers, and you would ruin your company by doing so, right? Because for sure things will go wrong. So you must be able to put this in some simulation. This could be either on a more high-level system where you have your machines. It could be per machine, that each machine is being simulated. So you must have this simulation environment.
So I'm going to jump in real quick
to train something there and optimize. Yes.
Let me jump in real quick. So I have a machine. You're saying I can take that machine, whatever it, and then put it into a simulation environment, and then run it. You know, this stays the same because I'm running, and then I can put it over here. Simulation. Okay. I just want to make sure that that. Did I get that right? Did I paint that right picture?
Yeah, more or less. Yes.
Okay.
It's a virtual, basically not so physical anymore. Then.
Yeah. Okay. Continue. I'm sorry. I want to get this right, because I think it's exciting stuff.
So the most important thing, of course, is that you need to know what is your objective, right? So what you want to achieve, what you want to actually do. Yeah. So you want to, let's say, optimize for cost, for energy usage, which could be the same. Years ago it was maybe not, but now it's getting more and more, of course, literally the same, because energy is getting expensive, or of course optimize for quality, whatnot. So you have to define the objectives to start with. This is pretty much also how EvoTorch works. So you, after you import the system, you have to define the objectives. Then the third one is to define your problem. So what you want to actually, so what is the problem environment? Then after that, and actually included with that, you also need to define on what compute you want to then run this optimization algorithm. So multiple CPU cores or multiple GPUs, could be hundreds of GPUs, and then you press the button to launch, and then the system is cranking out your optimized solution. So in a nutshell, that's more or less how it works. Of course, in reality, it's a bit more complicated, but we need a simulation environment, and in this simulation environment, then you run these evolutionary algorithms to optimize for problem solutions. Yeah.
And then once that runs, that simulation runs and reveals results, right? Then you can take those results and put it into your real world environment, right? And saying,
exactly.
Okay, yeah, it's saying this, that, and the other. See, we've got these simulations and we're running these. This is what you need to do over here in the real world to optimize. Do you ever, that makes sense. Now, do you ever go back and say, okay, I'm in the real world. I've taken the results. Does this continue to learn over here?
Right. Yeah, so of course, once you have done that, then the environment might change. So ideally, you want to want to automate this in some way. This is where actually a different term then comes into the play, as something that we have built as well at NNAISENCE. These are digital twins, so purely data-driven digital twins. To be clear here. Which goes far beyond the simulation. But of course, we work with simulation environments and use their input as well, and they basically help each other as well. So a hybrid solution between simulation and the digital twin is often what you need. So the PyTorch is the EvoTorch running on the PyTorch framework is then optimizing on this digital twin, and is basically then providing you the optimized solution depending on what criteria that you're looking at. So maybe make this very practical. Years ago, we got invited by the German automaker Audi to build a self-parking system. It was a very innovative project. At that time, we didn't have all these tools that now is available. And we only had a few months actually to realize to implement that. And so the job was to train an Audi car model to self-park, and of course do this better than any human being, and not just rectangular parking, but very complex parking situations, like you go in a field, right? Lots of cars chaotically parked, and I want to park back there, log it in, and then the car does it by itself. And we have done this by basically running these evolutionary algorithms in simulation. We had to build our own car simulator, since what Audi provided was not sufficiently good, although they had something, but we further improved that. And then we had a car simulator, and in this car simulator environment, we basically trained then using these evolutionary algorithms car parking over 500 years or so. And we're running this in just one day, condensed, because you can do this, right? So if a human being would have done that, it would have taken you 500 years, but it's not very practical to wait 500 years for training a machine. So we had to do this in virtual. That shows you that you have to do this in virtual, of course, otherwise it makes no sense. So once after 500 years, the system was converged, was stable, and we couldn't further improve. Then we transferred it back onto the real world environment of this Audi model car. So it was needed to basically park by itself, just using the onboard sensors, which was a camera and an infrared sensor and other things. And the car did actually better than any human being and never crashed. So that's an example where this worked very well. And you can take the Audi car and put there a machine, manufacturing facility, an industrial process. At the end, this is a similar concept. You train this in simulation. Once it works there, you transfer it back. Of course, first run it in some tests. In this case, was a model car, and maybe have some other test facility of your plant, right? And if it works there well, then give it a go. And the system is running this optimized much better than any human being, because we human beings are very good in certain things, but we're very bad, for example, in crunching hundreds or thousands of input data, right? For us to get to do this is completely impossible. And of course, machine learning and these algorithms, they do this fantastically well if they have the right tools and the right environment to do it. And EvoTorch is now exactly this. It's field tested, it's super easy to use, and it's highly scalable, much more than anything else you find out there. And the launch was super successful. Within 24 hours, we got more than 400 GitHub stars. So more than big tech firms got in years. That's very exciting for us. So obviously there's a big need for this out there, which doesn't totally surprise us because we see this, of course. And we're now pursuing this more and more.
Points of clarification, Ralf. When you did that Audi, that you provided that Audi example, for parking, how quick? So somebody Audi comes knocking on your door. Hey, we're interested in this, and then you say, "Hey, that's great. Give us a timeline on when you achieved, from our perspective, success."
Yeah. Well, that was before I joined the company, but the folks told me this was a 6-month project, because they wanted to demonstrate the outcome at the biggest machine learning conference in the world at the time. With and actually, I think 5,000 people watched this demo then live. And when it was shown there at this, so we had a 6-month hard date to do it. Today, it would be much faster to do because we have, of course, this expertise. We have this platform. We have done many, many other projects that I could speak about.
Yeah.
So, so that, of course, helps, right? So, so 6 months before something like this is super fast, I must say. But today you can do it much faster, quicker. That's for sure as well. Yeah.
So the other question I have, when we start talking about a simulation environment, you define objective. There has to be a discussion around the parameters, like, in the case of the parking analogy, the car will travel at this rate and do this and this. You have to sort of define a little bit of the parameters before really the machine starts to learn and say, no, we can do this, that, and the other. But there has to be a baseline understanding, right? Right.
Yeah, that's exactly the job of the simulator. You basically need to define what's what in what environment you actually are, right? What is your space, they call it, that you're looking for optimal solutions, and what I know, so that has to be defined totally correct, right? And of course, it's a different thing for an oil refinery or glass production or a car, but the principle is the same. You need experts, top experts in this field to basically write such simulations, such simulation environments typically, and that is needed. We can do it, of course, as well for them, since we're looking at this purely data-driven, so we don't really need to understand how glass or how metal or how oil is refined. We're looking at this purely data-driven. So you give us hundreds of sensor data, control data, right? And with that we fill our platform, and then we understand just based on this input data what's going on. And we don't have to be expert in that. That is the beauty of this approach as well. So you don't have to hire very, very expensive experts to do that. It's doable by. You still need to have, of course, an understanding of data and machine learning in this case. That's clear. But with this EvoTorch tool, at least the optimization part is something you don't even need to be a top expert at all. It's very easy to do. So
this is interesting because this has piqued my interest. So now I'm a manufacturer, got my manufacturing hat on. I hear what you're saying. I go out to evotorch.ai. I'm looking at it, right? I don't have the skill sets. I don't. Let's just sort of lay that out right now. But I'm able to connect with somebody at NNAISENCE, or because I've got to find somebody to trust. I got the value proposition. I see the need for it, but I need to find somebody to help me with this journey. Can I just go to NNAISENCE and say, hey, I see your EvoTorch. I like it. I'm interested in, trying it out, doing whatever. Where do I start? Is that can I come to you guys?
We were originally and still are a machine learning engineering service provider. So we have built these projects for large industrial customers, mainly also in other industries, but mainly there, and have investors from that space as well. So we certainly do such projects. That's correct. But you could, of course, also hire other folks that can do it. Now we have, of course, the unique understanding of all the details of EvoTorch. It is open source. You can look at the code. So if you're a big company and you have dozens of data scientists, they can look at each line of code and will understand that. And then if they still need support from us, we can provide that. That is something we are still doing. But theoretically, practically, you could, with such people, after you hire them, do such projects by yourself, or we help you to get started, and then you maintain it by yourself. That's of course also a possibility. So it's you're not dependent on this. That's the whole point.
Because
one
just
of the motivations
like any,
for going open source.
Just like any neural net, right? If I find somebody that I can work with, and then I learn, then I have that internal capability to being able to just say, EvoSource, we did it over here. We ran through, we achieved whatever our objectives and improvement, efficiency, whatever it might be. I think we could do it over here now. And we just do the same process, and we got the code, and we do you can begin to scale it within your organization to, achieve the objectives that you sort of lay out. I think it's exciting. I like the fact that it's open source.
Yeah, sure. It's a good approach in general by applying machine learning or other new technologies, by trying it out in a small problem and small problem space and settings. And if it works there, then expand in the sky. So that's very important. So you maybe don't want to start with the Audi project that I just mentioned, because that was super complex still by itself.
Yeah.
But if you have the team, why not? I mean, it's So
it's well, at least it's doable. And when we start talking about open source, let's say I go down the road and I do my thing. How do I loop back with you and say, hey, you know what I did over here? I learned this, and I did. Open source is sort of bilateral, right? It's like going back and forth. I can share my insights, my wisdoms, my whatever. Is that part of the community?
Yeah, we are building a community. That's probably the number one reason to go open source. We want to share what we have done, and now we hope, of course, that many other smart experts out there will take this and provide it. And it was very exciting to see in our own Slack communication when we launched this, when they had the press release launch, and when they published it in GitHub and Reddit and other communication channels. Suddenly all these top highly respected machine learning experts came on, and our guys were like, oh, let's say hi to him, right? Because we know them, of course, or know of them maybe, and have spoken. And then they congratulated us. They said, thanks a lot for bringing this out. This is super exciting stuff, right? And of course we hope that this, and quite sure that these folks now, they bring their own solutions in, apply this, and then publish this, and with that we bring the whole community forward. So that's of course the whole point of having this open source. That we don't think in our company we are smart enough to think about all the applications. It's absolutely impossible. So the world out there is too complex, and there are many smart people and trying to leverage this. And the start was super exciting. So lots of people are indeed excited and are now looking at this and start to apply it. So that's exactly what we're seeing. Yeah,
I think it's great. I think it's exciting. I think it's definitely in the direction that many industry organizations need to go. I like the fact that, one, it's open source. Two, it allows the small to mid-sized companies, whatever, let's say manufacturers, to participate in this digital transformation world, this machine learning opportunity, this AI, whatever it might be, and be able to do it in a way that helps them be competitive, more efficient, whatever it is. I'm all in. Ralf, how does somebody get a hold of you if they want to talk to you about what we just discussed?
You can just send an email at info@naisence.com, or my first name dot last name at naisence.com. Of course, you will go to the website of either naisence.com, and so then, or go to Evertorch website, go to the community Slack there. Then you immediately have our experts in there. If you have specific things for that, they know this much better, of course, than me. They have built this, and we have actually 20 years of expertise in the company for this evolutionary algorithm stuff. So we are total experts and pioneers there as well. Have invented lots of things prior to starting the company, and now we of course have solved many industry projects applying this. And as a last step, we now open source this library, this toolbox that allows people to do this very efficiently and scale. Scale is the most important thing, as I tried to explain in the beginning, because without that, it's just simply also too expensive to do it. But the example of the OpenAI shadow hand, which costs, I heard numbers of beyond $1 million just to train this algorithm. But possibly you can do this for maybe a couple $100 bucks or so if you completely paralyze this. And this is this makes it, of course, suddenly extremely affordable for literally anyone.
Yes, see, I love it, man. I just think that that's so exciting because we as a community, when I say community, industry, people around the world, we benefit from this. And because it's approachable and it's doable, then we all benefit. Excellent job, NNAISENCE. Thank you very much there, Ralf, for being on Industrial Talk.
Thank you very much, Scott. Pleasure talking to you.
Excellent. All right, listeners, we're going to have all the contact information for Ralf, NNAISENCE, Evo Touch, all of the stuff that we've talked about, Neural Net, and so on and so forth, out on Industrial Talk. So don't come crashing down my wall saying I can't get a hold of him, because it's all I'm on the website. It's right there, and you have all of the ability to be able to do what you need to do. So anyway, so stay tuned. We will be right back.
You're listening to the Industrial Talk Podcast Network.
All right, again, thank you very much for joining Industrial Talk, this ever-expanding ecosystem of problem solvers, leaders. Right here, you need to educate, collaborate, and definitely innovate. It starts here. Go out to industrialtalk.com. Find out more. Definitely, this is where it's at. And also, thank you to Ralf Haller. NNAISENCE is the company. The solution, the open source solution, is EvoTorch. I'll have the PDF, all the information about that. You need to simulate. You need to begin thinking about that. Your competition, how do you optimize your assets? How do you run those simulations? How do you create those parameters? All there, open source, all of the contact, all of the websites that are necessary for you to be successful. Again, let's make a quick little reminder. This is going to be September 12th through the 17th. I'll be broadcasting on site. If you are in manufacturing, yes, if you are in manufacturing, you need to be at IMTS 2022, September 12th through the 17th. It is a must. It has technology. It has connections, because you're all about education. Got it did. You're all about collaborating. They're all there. Multi-floor. You find them. And, of course, innovation. No doubt about it. It's at IMTS. All right. Thank you very much. Appreciate you joining me this day on Industrial Talk and talking about simulation. Excellent job. NNAISENCE, all of that contact info. Reach out to him. I'll have his stat card out there. So thank you again for supporting Industrial Talk. Remember, subscribe. Please subscribe. We're going to have another great conversation shortly, so do not go away. Stay tuned.